I'd be pretty embarrassed if I went through the whole class and I discovered I never turned the camera around. Anyway, someone asked, you know, can they claim rights? And said, oh yeah, it's almost always, they have rights to anything that you do on any company equipment, time, or facilities. And a lot of companies will actually have clauses say they own anything that you do on your own time and on your own equipment. Yes?
Is that claim to employee generated intellectual property, is that always in writing signed over by the employee, or is it?
It should be in writing. In other words, this is why you want to, I was responding to someone on Quora who asked this question, I said you should read anything that you're going to sign or any documents you get from your employer, you should read as if you're doing a code review looking for bugs. And if there's anything that's vague or unclear, you should ask them and say, hey, what about this? What happens in this case? And I'm going to cover all this post-Thanksgiving when I give the lecture, but just as my general rule is, get everything in writing. If you have projects that you plan to work on your own time, on your own equipment, at home, you should put down in writing and have them sign and acknowledge that these are projects you were working on, that you have all rights to this, that they can't come back and claim. I've had students who have worked for, I think, someone a semester or two ago when I gave a lecture said, yeah, I had an internship at Amazon and I looked at the employment agreement. Basically, they said they owned everything I do while I'm working for them, whether or not it's on my own equipment or on my own time. So just be aware. We'll cover all this in post-Thanksgiving. Any other questions, issues? I assume you're all just tickety-boo on your projects, making great progress, just dropping features left and right. Yes?
Intellectual property ownership for projects for this class.
That's an interesting issue, and that comes up occasionally because in some cases we have projects that are doing, what do I want to say? I've had teams of students who have actually been doing projects for outside companies. I've had other teams of students who've wanted to take what they're doing and push it forward. At this point, any intellectual property rights are going to have to be negotiated among you. There's no automatic ownership, but if someone says, hey, this is a great app, I want to take it forward, you need to go to your team members and say, you know, this is what I want to do, are you okay with this? Can you sign off? And I will simply say, if you have something like that come up, you know, just work it out. You're not going to be the next Qualtrics. You know, the most startups die, like 90% of startups die within 5 years. And I love startups. I've done two myself, but you just have to be aware that if you have dollar signs dancing in your head, chances are it's never going to happen. And just take a realistic and real-world approach to negotiating. But it's a good question, and we have had that come up in prior semesters. Any other questions or issues? Okay, facts and fallacies. Now, a lot of what Robert Glass says is repetitive of what you've already read in Mythical Man Month and Peopleware, which should be, you know, by the mouth of 2 or 3 witnesses shall all things be established. And it is that. What you'll find is that the same set of issues will come up again and again. I really like Glass's book precisely because of the approach of just, here are like 55 facts that you just need to know. And I'll tell you, believe what Glass writes. He knows what he's talking about. There are counterexamples and exceptions and so on and so forth. There are projects which are perfectly successful. There are estimates which are actually somewhat accurate, so on. But in terms of what you will find in most of your career ahead of you, this is what you're going to discover. These are going to be the truths you're going to run into. I think I saw a hand. Did you have a question? Okay. So, people. Most important factor is people. I've already said that. You've been hearing that. People matter most. software engineering is an intellectual and sociological effort. It becomes sociological as soon as you have 2 or more developers, or you have anyone else involved, like management, and so on. So, you know, once again, I would rather have a few really bright developers than a large number of okay developers, and I would rather have a few very bright developers than a large number of very bright developers. Unless I can divide them up and do like 3 or 4 or 5 projects simultaneously and have someone to manage all that. The ability to get along, the ability to mind meld, to come to agreement. This is a conceptual unity, and conceptual unity is not, chief architect isn't issuing dictates from on high. Architecture is, as I've said, a political act. The conceptual unity requires significant people skills, which was the lesson I learned through trial and error, a lot of trial and error at Pages. It requires talking and rolling, listening, accepting the suggestions and the inputs, making the trade-offs necessary. The problem is most organizations are not set up to find and hire great people. They're set up to, most organizations still treat software development like a manufacturing process. And we need 20 developers to get this project done, and as long as they meet sort of whatever minimal criteria we have, we're going to develop it, we're going to hire them and develop it. And that's not how software works, or at least it's not how it works effectively. Any questions or comments on this? Yes?
So, I mean, when you're hiring somebody, because you've obviously done quite a bit of it, I mean, nowadays they give us a leak code problem or a couple of them, and we solve through them. Did you ever do that style of hiring?
Well, we did at Pages, and I think I've already mentioned this, but it's a good place to bring it up again. Each time we bring someone in, I would do an interview, and I would have every other engineer do an interview. And she or he was free to do whatever they wanted, however they wanted to conduct that. But they weren't terribly lengthy. It's sort of like, they would have 20 to maybe 30 minutes with each of the other developers on the team. And we had to be unanimous. So what happened is, as the team grew, we got a more diverse approach to the interview process, and someone would find an issue that they would flag and say, I really don't feel good about this person because of X. I can't remember any situations where there was really strong disagreement. Usually if anyone on the team brought up an issue, the rest of the team was kind of like, yeah, I was sort of wondering about that myself, or it was like, well, I didn't see that, but that's a serious issue, and so on. That was the most effective process. Boy, it's hard. It really is hard. I mean, I've already said this. Most effective metric for hiring someone is the strong recommendation of someone whose opinion you trust. Someone who actually has seen this person in action and says, yeah. Well, because it's possible for someone to really have a great looking resume, to do well in the interview, and to be a failure within a real world development setting. Or at least sufficiently mediocre that you're kind of like, I don't know about this. It's hard. And I'll point right back to professional sports. Again, one of your extra credit readings, or in the set of extra credit readings, is the article that Ruby Rayleigh and I did, where we beat the sports team metaphor to death. Ran into the ground. Anyway, but that said, look at football teams and what a challenge it is for a lot of football teams or baseball teams, whatever their preferred sport is, to repeat year after year with almost the same personnel and the same coaches. I mean, for those of your Kansas City Chiefs fans, You know, it's kind of like, what's wrong with the Chiefs this year? Or name whatever team you want, because there are teams that are doing great, and there are teams that are just struggling, or teams that you expect, you know, Clemson. I'm sure there are lots of Clemson fans who are wondering what the heck happened with Clemson. So it's not just people, but part of it is the chemistry of the project and how the project unfolds. Yes?
Related question. Earlier in the semester, we talked about TEPIS, which is
Talk about.
TEPIS, T-E-P.
Oh yes, TEPIS, yes.
And when it comes to hiring, because my wife is actually in a position where she's a senior member of the team and she's been able to participate in interviewing new hires. And so this raised the question for me, if given a choice between two candidates where one is technologically, or is just a talented genius, but is kind of socially abrasive versus...
Madonna is the term.
Yeah, versus someone who's a great team player but just really doesn't grasp technical concepts very well. Would you just pass on both and try again, or would you pick one or the other? What would be your process?
That's actually a very good question, because I've been through that. I've been through, one of the people we hired at Pages was very brilliant, technically brilliant, and it turned out as time went on was more and more socially abrasive, very critical of the project, of the company, of the other team members, and so on. And in spite of his contributions, we finally let him go. Because of that. And it's why it's what I cover with the professionalism and under, you know, TEPIS. Plays well with others. This sounds like a cop-out, but it depends on the nature of what I need that person for. If they are an average developer, but they are diligent, they get their work done, and so on, if I have tasks that I can hand off to this person, I will take that over a abrasive genius, because I've worked with abrasive geniuses, and in the end it isn't worth it as much as you might think it is. The sociology, if you're dealing with a team, the sociology is too important.
Perhaps in a case where you need a genius solution, you'd go with the genius and
You go with the genius and see if you can put her or him off into a room by themselves. And, you know, slip stuff under the door. And sometimes, you know, sometimes that works. Sometimes you can, if the person is really truly gifted and bright, you can, you know, put them in their own little cubicle or their own little office with a door that closes and say, you know, work on this and let us know when you're done. And basically, it's the classic thing of what you want to do with your architecture, which is loose coupling and high internal cohesion. So you put this person, give the person tasks that they can work on without having to interact with others. And if your project allows that, that's great. If your project is going to require a lot of interaction with other people, an abrasive person can destroy a team. They really can. And it's just not worth it. Okay, that's 15 minutes, first of like 20 slides. Lots of studies over the past 50 years that have shown differences in productivity between programmers. And if you can find someone who's really, really good, hire them. Pay them well. Keep them happy. It doesn't mean that they can solve all your problems with you. And if, again, to your original question, if they're abrasive, they may not be worth it. But just be aware, there are people who really are truly gifted and brilliant. I don't count myself among those. I'm more the give me a month to chew on a problem and try and figure out and look ahead and see what all the issues are. So I tend to be slow to start because I want to look at everything. I want to think about stuff. I want to take a long time, and then start with a small piece of code and build up from there, whereas I've known developers who can, go away for a weekend and come back with several thousand lines of great code. There are people like that. But you can't count on finding them. So you have to build your team, your organization, to maximize both the productivity and the satisfaction of the people who are there, because if you neglect the satisfaction, then you do get the density effect. Any comments or questions here?
Actually,
Yes?
So in the interviewing process, as a person that's like that, or you, how do you discern between those that need some time to chew on the problem?
It's very, well, and it's hard. I have, which I think is a pretty nice professional track record. And I'm well aware that how some of the companies hire nowadays, they would never hire me, besides the fact that I'm almost 70, but set that aside for a second. Because something like that can be hard to discern in the course of a 20-minute or even an all-day interview. This is where you really need this, and this is why I keep coming back to, though you often cannot get it, but you really want to talk to people who've actually worked with this person and said, what are they like? What were they like in doing the actual project? How did they get along with others? Did they, come up? Were they able to solve stuff? Were they able to get stuff done? My sister Deirdre, who was actually the first programmer at Heritage Pages, and then Mike and Vic, the founders, were very patient. It's like, nepotism's not a bad thing. Deirdre was not the, thousands of lines in a weekend type. Deirdre was the type that her code worked. She might take a little longer to do it, but she had analyzed it to a fare thee well, and her code just worked. And she would deliver working code, and it would just continue to work, and you didn't find very many bugs, if any, in Deirdre's code. And that was one of her strengths. I don't know if I've told this story. She had a master's in education, was a reading specialist at an elementary school, and as she put it, was tired of wondering every August if she had a job in September. So she signed up for a programming class at a local junior college. And I was living in Houston at the time, and she was in San Diego, and she called me up and said, I've been taking this programming class. She says, all my programs run correctly the first time. Is that normal? I said, oh no. No, that's not normal at all. But it was. She would just very carefully think through everything before she was not a code and go person. She was someone who would think carefully, analyze everything, and her assignments, time and again, she'd submit it and it'd run fine the first time. She'd pass the assignment. I said, you found a new career. And we talk later about how she ended up getting all the obstacles she faced getting into and actually doing software development. Her first job. How many of you have seen Top Gun, the original with Tom Cruise? Kelly McGillis, what does she do? She's a computer analyst analyzing data for Top Gun. She drives a black 61 Porsche, I believe, in the movie. That's my sister. She was analyzing data for Top Gun. She drove a black Porsche like that. They actually filmed Top Gun while she was doing this at Miramar. And I've often wondered, met Tom Cruise, met some others, I've often wondered. Character was already there, but I've always found it very amusing that was basically, and yes, she did marry a Top Gun pilot. Anyway. Okay, adding people to a late project makes it later. We've already talked about that. Working environment has a profound impact. Of course, this is pretty much what we've been going through all through Peopleware. Hype. This is no silver bullet or lay a trail, which we've already covered, both with Brooks and with DeMarco and Lister. And it's still People are still looking for silver bullets, whether it's a technology or methodology, and you'll see this when you start reading. How many of you started on Webster 6? Someone looks like they finished it. I saw someone with on grades that had a point there. This whole idea that this technology or methodology is going to give you something for nothing. It's going to make some major breakthrough. It is a silver bullet. Software is just hard, and it frankly keeps getting, it's gotten harder in a different way. You go back to my early days, and I'm doing assembly language coding, and I've got to keep the memory map in line, and I do things like write graphics libraries from scratch. I wrote the whole graphics library from Sundoc from scratch. I was just working with the 6502, and basically didn't have a whole lot to draw upon. Nowadays, you have these massive software suites, and you have to somehow make them all work together. And you have to understand all the various APIs, and you have to get stuff to coordinate. So you've got levels of complexity. You know, you're spinning off websites on AWS, and you've got tools that help you, but at the same time, you've got greater levels of complexity. So this is an important thing to learn, and this is what management doesn't understand. Learning a new tool, technique, methodology slows you down. I've already mentioned in failed projects I've reviewed as an expert witness, I've repeatedly seen when after typically the second slip, the development firm suddenly adopts Agile out of the blue. We're going to adopt Agile. This will get us back on track. And almost always they have no one who has actually delivered a working system using Agile. So they leap into it and they use it for about 2 months and then they abandon it because they really don't know how to use it. And they were expecting it to magically solve the core problems, which it really doesn't address. Core problems are usually really bad code, septic code, and or lack of quality assurance. And the great pitfall, hey, right around. Yay! Thank you for reminding me. Yeah, I'm not going to flash this at any of you. I'm afraid to blind you. The great pitfall. Looking at this. So there we go. Great pitfall. Adopting a new tool or technique for a mission-critical project. You're going to adopt a new language, a new methodology, whatever you want to do, a trial project that is not mission-critical, where you can come up to speed, learn, make your mistakes, so on and so forth. Time and again, I've seen organizations say, yeah, we're using, well, at Eric, they were doing this project, not the one I was originally hired for, but one I got sucked into, doing this network management for MCI, and they were using this 1.0 release of a development environment for a language that no one in the division had ever used before, an obscure language called ASN.1. Anyone ever actually heard of ASN.1? It's for this interesting realm of network management where you have devices that have code and the devices talk to each other and so on. So the company is basically given the developers a week of training on ASN.1 and they're waiting for the 1.0 release to start coding, and they think they're going to develop the software in a matter of a couple months. And this is one where I stood up and waved my hands and said, no, this is going to go south so quickly, and it did. It's always nice to be right. Anyway, software developers talk a lot about tools, evaluate a few, buy a fair number, and use practically none. Actually, I would say most of us use IDEs very heavily, and I think tools, Glass wrote this in 2002, I believe. Software tools have become more widely useful, especially when trying to spin up websites, using various off-the-shelf tools, components, containers, web services that are online, and so on. But let me ask this, and the last question here. What have you learned about, and have any of you had uncomfortable or unpleasant experiences with some of the tools you've been using in your projects for this class? Anyone? Anyone? Hey, look at that, you guys are doing well. I've already mentioned that we've had teams in the past that, for example, we're going to use, I think it was Unreal Engine, and one of them was actually experienced with Unreal Engine on the Mac, but they were doing it on Windows or the other way around, and discovered that there were sufficient differences that they basically had a steep learning curve anyway. Part of the problem is tools are often mandated from the top down, and they aren't the best tools for the project. Accelerate is one of the books. If there were one book I'd really recommend on the extra credit reading, it's Accelerate by Fosgren et al. I've actually used it a couple semesters, but I went back to Fallacies and Fallacies because I like that better. But it talks about modern software engineering practices and what the best practices are for the companies that are actually achieving stuff and getting stuff done out there. Any questions or comments here? No? Okay, estimation. Two most common causes of runaway projects are poor estimation and unstable requirements. Usually both of them go hand in hand. Software estimation is really hard for all the reasons we talked. Because and we're going to talk about that as we go forward here. Estimates are usually done at the beginning of the life cycle, often before the requirements are defined and thus before the problem is understood. And of course, if you throw armor in here, the more novelty you have, the more ignorance you have, things that you know you're going to have to solve but don't know how to solve them yet, and a set of problems that you don't yet know that you're going to have to solve, and you don't yet know how you can solve them if in fact you can solve them. Anyone have some estimate stories that you'd like to talk about? I mean, I already told you about Pages. We were a full year late in shipping. And I was the one who came up with the original estimate. So this is pretty much where my whole career went 90 degrees in a different direction. And I switched from software architecture to why projects fail. Our project succeeded. We did ship. But it turned out we shipped on a platform that didn't have the market share enough to keep the company going. That said, I have ever since then, for the last 25 plus years, been focused on why do projects fail. And the difficulty, the challenge in estimation is one of the most critical issues and remains one of the most critical issues. It's what keeps me in business as an expert witness, because time and again I'm called in to disputed projects where the original schedule has been blown up, stretched 2 or 3 or 4 times what it was originally supposed to be, and finally ended in litigation. Comments, questions, personal horror stories, experiences? Yeah.
I remember in my last internship, super high functioning team. We operated without any kind of estimation at all. We had 6 projects kind of going simultaneously that somebody was in charge of. And I remember they hired a new manager 2 levels up or something, and he wanted just a date on each one. So we had a 5-minute meeting where we went through each project and we all just voted on a date, and then totally forgot about it until the dates rolled around. And he's like, "Are these done?" And we're like, "Oh, some of them are and some of them aren't." No, it was interesting how pushed to the side it was,
DeMarco and Lister actually say, you may recall that in Peopleware. They talk about this development group, I think over in Scandinavia, where they would not set deadlines at all. They would just work on the project. And that they actually had a relatively high success rate in delivering stuff. Your estimate actually ties on to something else, which is one of my techniques when I'm called in to a corporation to review a project that's in trouble. I will, when I get it to the mid-level managers, I'll say, okay, how long do you think you know, this is going to be done. Say, well, we think we're going to be done end of December. And I say, would you be willing to bet $10,000 of your own money on that? Usually they say no. I said, if you had to bet $10,000 of your own money, when do you think it would be done? Well, I think probably June of next year. The problem is we often have no skin in the game in estimation, and as per Brooks, we often lack the courage to basically say, I don't know, or it's going to take a lot longer than management wants to hear. That's hard. And once again, go to management, say, okay, we can deliver something end of December, but we're going to have to drop the following set of features. We may squeeze one or two of them back in, but if you really want this done, here's what we know we can get done between now and December. Well, we have to have all of them. Well, you can't get all of them. Yeah, that's the simple truth. The writing software is not like building houses. It doesn't lend itself, unless you're doing the same thing over and over again. I was interviewed with a company that was actually very good at implementing customized versions of their software for utilities, power utilities. But here's what they had. They had working software, and they would go through and work with the customer, and they'd produce about a 200-page document that was every single screen in their software with exactly the changes and customizations for the customer. And then they'd go to the customer and say, okay, it's going to take us this long and it's going to cost us much money. Because they had done this, A, they were doing the same thing over and over again, so you're out of the way with armor, you know what you're doing. B, it's broken down on such a level of granularity that it's like we know exactly how long this is going to take to customize this screen, to add these changes, to hook into the stuff on the back end. And they were actually very successful with this approach. Most software is not that way. Most software, you have some level of research and investigation that comes into play. This is another important point. Often, now he says most. I don't know if this is always the case. I think he's probably saying sometimes upper management mandates it, but he says estimates are made by upper management or marketing. This is marketing saying, yeah, we have to have this set of features by December. And the software developers are basically laughing and saying you want to win. So when software estimates are not being done by the people actually building the software, and as per your story, where it's like, well, let's vote on this one, we think we're going to have this done. Often it is dictated from above. I already told you a story of Pages where I had an estimate, and Larry came back and said, this is too long, I need the 6 months sooner, and I sort of said, well, this is our estimate, but I'll rework the schedule. And of course, he came back after we missed that earlier deadline and tried to yell at me, and I pulled out my memos. This was my original schedule. I think my original schedule was off. Any comments or questions here? Oh, sorry, yes.
I had a question with these experiences you've had where you've seen companies that, because of poor estimation or other factors or subject code and all these things, you're expecting their project to fail. Have you ever had an experience where your recommendation or whatever was kind of wrong and they actually were able to succeed?
Well, usually by the time they bring me in, they're already in deep trouble. But yes, and I think I've mentioned this. There was a large financial company whose name you'd recognize, a credit card company that had an internal project to do a brand new re-engineering of their customer-facing site for customers to manage their credit cards. And the internal IT department, by sheer dint of effort, actually delivered it on time. But they have a lot of technical debt, And they said, you know, we really need 6 months to clean up all these problems and so on. And upper management came and said, oh no, here's this whole new list of features we want you to implement in the next 6 months. And we got brought in and we basically went to upper management. We reviewed it and said, no, you need to let them fix this technical debt. You need to scale way back the new features. You need to prioritize these things. And they listened to us and they scaled it back and they changed it and they had a successful 2.0 delivery. So yes, sometimes companies listen. Not always, but sometimes. Okay, software, this is an important one. Software estimates, you know, I keep wanting to shine here and be able to see it back there. Software estimates are rarely adjusted as the project proceeds. This is the 3-week issue. It's not that they are, you know, every month saying, okay, what's our new estimate of the deadline? It's like we're aiming for end of December, and the second week of December, it's like, oh yeah, we're going to slip 6 months. The part of this is the thermocline of truth. Group, you know, folks down below know that, no, there's no way we're going to make that. And the information just isn't getting up there. Sometimes it's a lot of self-delusion all the way through. And what you really need is a constant readjustment as to when you think it's going to happen. Even if it's the painful truth is you may be wrong again. Now that was, you know, that year that Pages was late, every month I was part of the team that had to go to the investors and explain why we weren't going to meet our current deadline and what our new deadline was and why they should even believe our new deadline. And why we had there, I can remember sometime probably about 3 months after our slip, talking with some of the engineers, and at this point our new deadline was I think end of the year, like December. And talking to Kevin Berg and him looking at me and saying, what if we go past December? And I remember thinking, oh, that's just too horrible to think. We actually shipped in March. We went 3 months past December. So it can be very hard to admit to yourself. And it can be sometimes very hard to know just how long something is going to take. As I've said before, that year was the most agonizing year professionally in my entire career, because I learned how wrong I was about so many things. And it forced me to rethink all the things I thought I knew about software development, particularly about estimation, which is why I'm teaching this class now. And always remember Brooks. I keep looking there. It's like, isn't it going to show green there? Sorry. Take no small slips. If you were given a chance to change a project, figure out how much time you need, double it, and ask for that. Do not take small slips. Classic story here. We had a project at Fannie Mae. This is where I was overseeing a group of about 25 consultants. They were doing re-engineering of a number of projects. They were coming up with a new technology for actually building applications. And the mistake number one, the team that was doing that, the same person was both the chief architect and the software and project manager. That was my second experience as to why you don't want to have the same person in both those roles. It was clear they were not going to make the original delivery of these development tools to Fannie Mae. And the vice president of Fannie Mae, who was in charge of this, went to this individual and said, okay, you have a get-out-of-jail-free card here. Give me your best estimate as to when you think you'll actually have it done. And this person, the architect slash project manager, said, in 3 weeks. And she asked him like 2 or 3 times, are you sure of this? Then she dragged me, because I was over him and over all the OSG people, dragged me into her office. She was furious. She says, I know it's not going to be 3 weeks. I said, I'll be surprised if it's 3 months. He had a carte blanche here to ask for as much time. He could have asked 6 months. I would have given him 6 months. And she was very angry and frustrated because this was something that she was going to have to report up and deal with the consequences when they missed that 3 weeks deadline, which they missed. When you have the opportunity to take a slip, figure out, we're back to our estimation tools, figure out how long you think it's going to take, double it. Take as much time as you can. This is interesting. Since estimates are so faulty, there's no reason to be concerned when they don't meet it, but everyone's concerned anyway. It's using research analogy. It's a bit like, well, you know, we have until the end of the year to cure cancer, and if we don't get it cured, then all is lost. Now, part of the problem is that the software has, unlike, say, a cure for cancer, software has a direct impact on the bottom line of the company. They need to know when they're going to have it. But it is better, and this is one of the advantages of the Agile thing, it's better to say, here's the feature that we want to add this week or this month. Let's do incremental improvements. Let's have something that we have in production. And to, as noted here, DevOps appears to be an attempt to sidestep the entire schedule focus, have constant development and deployment, have something always there in operation, and keep working. This is hard because everyone wants deadlines. Everyone wants to know when can we ship this product, when can we get ship the next version of it, what's going to happen, and you just need to keep that drop feature approach. There is often a disconnect between management and their programmers. Oh yeah. Boy, that's true. Notice the second point here. When asked why project was late, programmers said unrealistic estimates, lack of expert resources, poorly understood scope, late start, all at the start of the project. And we're back to all the important mistakes you made the first day. When you're starting a new project, you say, we're going to deliver this in a year and a half, and it's going to have this set of features. There is so much that can go wrong between now and that year and a half that unless you're being putting a lot of cushion in the schedule, there's a good chance you're going to miss it. This is an important point, and this is one that it's easy to pass over, but it's really important because this does get to the heart of armor. The answer to a feasibility study, in other words saying, can we do the software project, is almost always yes. And he cites Jerry Weinberg at a conference saying, how many of you participated in the feasibility answer where the answer came back no, and no one raised their hand? This is the confluence of both the drive of management and marketing to want to get this new product, and the fact that we as engineers never want to say, no, we can't do that. There are projects and products you just shouldn't attempt. And there have been millions and up to billions of dollars lost on projects that never should have been started in the first place. And once they start, you get the sunk cost fallacy. Sunk cost fallacy is, I've already spent $50 million on this project, surely with another $20 million, we can make it work. They spent $20 million, and surely with another $10 million, we can make it work. You spent $10 million, you're now up to $80 million, it still doesn't work. That happens all the time. One of my mantras is that most software projects do not fail fast enough. The plug is not pulled soon enough. There are times when you reach a point and say, let's stop, rethink what we want to do, because we're just going to sink a lot more money and time into this project, and at the end we're not going to have something that is going to be worthwhile. And part of what you have to understand is there's a lot of software projects that actually go into production that don't produce the return on investment that was anticipated or required. In other words, if you're spending $5, $10, $20, $100 million on a new software system in-house, you expect to get a certain return on it. You're gonna, and frankly, from a business point of view, it's usually reducing headcount. But, or for your commercial product, we want to get so many sales, and you have companies spend a lot of money to either develop and deploy internal systems or develop new products, and basically lose money on it in the end. Reuse. Reuse. I just answered a question on reuse today on Quora. Reuse was such a big factor in the 90s. It's like, we're going to build software integrated circuits, software ICs, and components. You can build software just by plugging these in together. Here's the reuse paradox, which I may have already said, but tough, you're going to hear it again. The more reusable a component is, that is, the more generalized it is, the less suited it is for any specific application. The more suited a component is for a specific application, the less reusable it is. And so you have this challenge where trying to do software, what he calls reuse in the large. This works best when you have low coupling, high internal cohesion. Things like graphics engines. Things like, microservices. Things that are easy to put in a box and simply call and make use of. And even there you end up working around. This is sort of the development equivalent of buy versus build. If you can buy technology that will do 90% of what you want to do that and live with it and work around it. If it's something that's your competitive edge, you're going to have to build it yourself. But reuse was a big thing in the 90s. Of course, he's writing this in 2002, pretty much just as the reuse movement is winding down. I have probably 6 or 7 books that are all about software reuse, all published in the 90s. And it just never panned out in that level. I also got a whole set of stuff on service-oriented architectures. I don't have any books on microservices. I probably should get some. Anyway. So reuse in the small, which are libraries, we've been doing pretty much forever. Software libraries are old. APIs, APIs for operating systems or particular environments. That's all well known. But the idea of, I've got this component, I've got my sorting component. This can sort stuff, and I'm going to use it. Well, I may have a sorting routine in the library, but the classic example of Fannie Mae, and I've probably already mentioned this, is they wanted to come up with a universal loan object and end up with this bloated mess. Because even though the fundamental abstraction for Fannie Mae is a mortgage loan, different systems had entirely different views on it and needed different information and operations. And the attempt to have a single loan object at Fannie Mae, you end up with this big bloated mess with hundreds of data fields and hundreds of methods that no one wanted to use because it was too difficult and too bloated. More stuff on design patterns are a good form of reuse. I don't know if I already mentioned this. Fannie Mae had a big reuse project that I was helping them with, and the single most, they developed a reuse library, and almost nobody used the stuff to use a reuse library except for shell scripts. Everyone loved the shell scripts because you had someone would really have like the perfect shell script that could go through and do a set of operations on a set of files and do this and handled all the error conditions and so on. And once someone checked that into the reuse library, it's like everyone else started using it. I was like, that's so cool. what I've been looking to do, so. Complexity. This is an important metric. Now, I don't know what he has to support that, but I believe it. The software solution complexity expands at a faster rate than the requirement complexity or the problem complexity. So if you're adding, each time you add a new, and this is why dropping features. If you add a new feature, you know, you've got 10 features. I'm adding an 11th feature. Okay, if it's a simple feature, it may be a simple add, but if it's a feature that interacts with all the other features, you're adding more than 10% to your solution. You've got to suddenly deal with this in all sorts of different places. This is why scope creep is so devastating. You have people say, oh yeah, by the way, while you're at it, here are these other features we want you to add. And the solution complexity just exploded. You know, we had 25% new features, and we have a doubling of the solution complexity. And number 22, 80% of software work is intellectual. It's thinking things through. It's trying to figure out solutions. It's the armor diagram with all the jagged things going to dead ends as well as finding actually working code. It's creative. It's almost not clerical. And as per my point here, this is why AI isn't going to replace us. Same reason why case tools didn't allow business people to replace programmers in the 90s. And it's why low-code and no-code solutions aren't going to replace you either. They allow people to do straightforward things. They don't allow people to solve new problems. That's what the intellectual creative effort is for. And that's why there will always be demand for software engineers, at least for the foreseeable future. I have my doubts about us ever achieving strong AI because I've been watching AI for almost 50 years. And we've been 10 years away from strong AI for literally since the 1950s. And instead, it's just sort of like little one-off and niche areas. Okay. That's the end of the lecture. Any questions or comments? Any last feedback on any of that? What you've got for this week, you're done with all your team deliverables. Your team needs to submit a status report this week. You've got a podcast that's due by Saturday night. For next Monday, read Chapter 2 and keep reading on Webster 6. I will probably next week do an early midterm review, just to get your mind in that set. But it's because of the changes I've made to the reading assignments. You're basically prepping for the midterm right now. You're doing the exact same thing that's going to be asked on the midterm. In the next 2 weeks, I want you to do code reviews, and you check this off individually. It's an exam with a yes/no answer, which is just sit down with someone on your team and look through their source code. Find someone who has source code. Some of you may not have written any. And you've got 2 weeks to do this, and if necessary, I can stretch the, in fact, I take that back. I may stretch the deadline out for a couple more weeks. Because a lot of you are going to be cranking for source code between now and the 18th, 15th. 15th is the work in progress demo, and we'll do another midterm prep there. Midterms on the 22nd, and the final demos on the 6th. So, and there's no final, as I've said, so the midterm, I deliberately pushed the midterm late for 2 reasons. One is because you got midterms in other classes. And I want you to get past that. And second, because I want you to have a chance to do most of the reading. By But I don't want you to have to worry about a final. So technically, I think I'm supposed to offer a final, but I don't. No one's complained so far. Yes?
Is this midterm administered in class?
No, it's a, midterm is on Learning Suite. You have 24-hour period to do it. Open book, open note, open everything except not open classmate. It'll be 3 hours timed. It's 5 questions. We'll go through all that next week. But just know it'll be open book, open note, 3 hours, 5 questions, and the questions they won't be identical. They'll look just like the questions you've been answering for mythical man and so on. Here's a scenario. Name 3 risks and 2 mitigations with at least 1 citation for each. But citations can draw from any of the reading you've done, any of the lectures, so on and so forth. Yes?
Question about the code reviews.
Yeah.
If we're doing pull requests as we go and reviewing each other's code
Mhm.
whenever we commit and whenever we make changes.
If you've been doing code reviews as you go along, then just check it off and see, yeah, I got
Cool.
code